Hey friends, welcome back to another video. Today I'm here with a very special guest. His name is Sriram Suryanarayan. He is the director of innovation at engineering consulting firm called Kinectrics. So Sriram, welcome. First time I heard Sriram was actually at the NYGN workshop, at a workshop for youth, and I learned some really important takeaways, especially in terms of innovation, in terms of growth for young industry professionals. So I really want to deep dive into the world of innovation because the nuclear industry sometimes is seen as a backwards industry that's not very highly technological. It's not advancing. We want to change the narrative on that. Deep dive into like what does innovation from that consulting perspective look like?
Let me start here. Nuclear industry works with all the cool technologies that a lot of the younger generation of folks who are aspiring to enter into the industry look at. This includes artificial intelligence and machine learning. This includes virtual and augmented reality. This includes advanced manufacturing, 3D printing, and qualification of components for use. This includes smart materials. This also includes medical isotopes, the latest and the greatest medical isotopes to cure diseases like cancer. The nuclear industry is involved in all of these technologies. And one of the key things to keep in mind, especially with regards to innovation, is we are innovating as an industry, not just in terms of new reactor designs. We are also innovating in many ways in terms of technologies that we have adopted for making things better, faster, cheaper, more efficient, more cost effective, more safer, etc.
When it comes to innovation in the industry, from a high level overview, what are some of the areas of innovation? Like, could you identify some of those and where the industry is leading in that area?
Let me start off with artificial intelligence and machine learning. So we have a team of about dedicated 12 people who are experts in this subject and who are working both in for on several internal innovation projects as well as for our client organizations, and they are focused on a number of areas. This includes auto analysis. This includes computer vision. This includes elements like deep learning, natural language processing, etc. Now, in terms of applications, where we can look at is auto analysis of inspection data, for example. These are inspection data from core can-do components like pressure tubes and feeders, etc. So that is one element. Removing chatter or noise from signals is another element that we are working on. Uh, Computer vision, this is for automation and digital innovation is an area we are looking at. Engineering change control processes, making them more efficient, is an area we are also focused in. Now, having said that, the latest and the greatest that the next generation of aspiring talent that is going to come into the industries, they are very well versed with AI chatbots. And what we are doing in that space is we are developing our own chatbot for several applications, both internal as well as client facing applications. So we are working very closely with our utility partners. And there are a number of projects we have completed for them. There are also projects that are in final stages, pre-implementation in terms of quality and submissions to the regulator, etc. And they will eventually be implemented. So it's going good. So artificial intelligence is one area. One thing that I'm personally very passionate about is medical isotopes because that saves lives. So that's a big element of what the nuclear industry does. Whether it is cobalt 60 for sterilization of PPE or medical equipment that is used to treat patients, or generation of medical isotopes for treatment. As an example, Bruce Power, along with Isogen, which is a joint venture partner between Kinectrics and Framatome, has developed one of its kind system, isotope production system, that makes Unit 7 of Bruce Power the first power reactor to generate lutetium 177 that is used for treatment of cancer. So that's an area that we are very passionate about, and we are also looking at next generation of isotopes in that area. In terms of virtual reality, virtual augmented reality, we have a tool called Adapt Advanced Dose Exposure Planning Tool. So what this tool essentially does is it helps with dose planning, with work management. It has a number of input data that goes into those tools. Everything from CAD models to 3D laser scanning to also shielding codes, things like origin code, MCNP, Attila. It all brings all of that together to have a virtual reality tool that a health physicist or a work management professional can plan the work. It can also, in virtual reality world, you can add shielding and see how what is the best path for a worker to move around the plant and do their maintenance or inspection work. It also can be used for training. So a lot of cool technologies that I talked about.
I want to deep dive into one of those technologies that you mentioned, radioisotopes. When people think of radioisotopes, basically you have a CANDU reactor, it's a neutron source. You know, you throw materials there, right? While it's operating, and they get neutron activated, right? And then ultimately those become radioisotopes. They're harvested over a period of time. And so, how complex is a project like that? Like, what types of innovation are applied in terms of project complexity?
The project is technically complex, but having said that, I think the success of that project depends on the people. And this is how I describe it. In terms of success, how do we be successful in typically this unique, innovative, novel, first of a kind projects? Is you need to have the right people. And I think our claim to fame has been three elements for success of projects like the Isotopes project. Is our people. Strong technical knowledge coupled with strong presence in the acumen in terms of project management and design engineering and tooling space, etc. That needs to come together. The next one is our facilities. We have state of the art facilities where we can do mock ups, we can test things out before it can go into the field. The third thing is our processes. There are ways to doing things in an effective, efficient, innovative way. And as long as you have the three elements come together, that helps success of the project. And I think more importantly, we are in the can do world. It's the can do attitude that matters. Ultimately, with regards to our Isotopes project, it is several team members who came together as one Kinectrics, along with collaborations with our client organization. In this particular case, it's Bruce Power and our joint venture partner Framatome. So there are so many collaborations that have occurred. So the elements are having the right people, the processes, the facilities, and the right collaborations, and a can-do attitude to top it up is what results in project success.
That's phenomenal. I love that overview because a lot of folks watching this video right now, they might want to get into the industry just to get a bit of a better scope of some of these technical projects, what it takes to take these on, what it takes to drive innovation in the industry. I want to ask you about your journey into getting into the innovation space. Like, tell us about how you got into the industry. Tell us about what inspires you to be the director of innovation. Like, what your role is right now at Kinectrics.
That's a very good question, Osama. I started in the nuclear industry in 1996. And after completing a master's degree in analytical chemistry, focusing on pharmaceutical analysis, I joined the nuclear industry in Baba Atomic Research Center. So it's a national nuclear lab. It's a premier national nuclear lab in India. They are one of, in my humble opinion, they are one of the best nuclear training schools in the world. I was very fortunate to take some spectacular courses that kind of broadened my horizon in terms of the breadth of nuclear technology itself. And I spent about 5 years there while working in three main areas. One is recovery of uranium from ores, nuclear fuel reprocessing, and management of high-level waste. Essentially, process development. This also I was also had a lot of publications and got recognition from the various bodies in India. This includes the Young Scientist Award by the Indian Council of Chemists. That was very encouraging to me. That kept me motivated to do more and more innovation. Having said that, after completing my PhD there, while I was working in about 2002, I decided to seek new pastures. I wanted to learn more. I wanted to broaden my horizon. So I came to Canada as a postdoctoral fellow in McMaster University, and there too, innovation followed me. In my initial week itself, our industrial client then was 3M Canada. They came up with a very interesting challenge. They brought two products of their competitors, which are filters, and said, make one. It's a filtration technology. Make one that flows 10 times faster without loss in separation. So if you look at a very simple concept of a coffee filter, in order to have more water flow through it, you'll have to increase the pore size, which means you might lose some separation. Some of the coffee powder fines may come out. But that's the kind of challenge we had. So we had to let create a filter that flows 10 times faster without loss in separation, which is considered counterintuitive. The long story short, we came together as a team and we solved the problem. We came up with a interesting innovation concept called anchored gel membranes, which is now widely used in the industry in a number of applications ranging from water treatment to bioseparation and controlled drug delivery for that matter. So after about 5 years in McMaster, I decided that let me go back to my home ground, which is nuclear, and I joined Kinectrics. I've been with Kinectrics for close to 17 years. During this period, I must say that it's one of the best places to work. I got solid mentorship there. I mean, when I joined the team, the company was around 250 people in size, and about 10 out of the 15 staff members in my team had PhDs. So I was surrounded by world-leading experts in a number of subjects, and they mentored me. And as a result of this, I was also able to develop several new processes for challenging waste streams. These are considered as what one refers to as no path forward or orphaned waste streams, which the conventional, vendors or that deal with such waste streams are not able to take. So that's why it's considered orphaned or no path forward. So we came up with very novel solutions. One of them being what is called universal separation process. That is the only process known in the world that can remove all radionuclides from organic mixed waste, so that the bulk of the waste can be rendered as what is called free releasable. The other thing is our PCB destruction and decontamination technologies. Again, very challenging waste stream, small volumes, but challenging nevertheless. So we have some innovative proprietary technologies that we have deployed for orphaned, what were initially considered orphaned or no path forward waste streams, where we successfully decontaminated PCB contaminated materials. Those materials that were both PCB and radiologically contaminated, we dealt with it very successfully. Having said that, that also brings to the forefront the issue of what is called PCB end of use deadlines. So that is something that the industry is looking at, and we have a solution for it. And these are proven solutions. In addition to that, I also worked in the power plant chemistry area, where I'm very happy to say that the projects that we did for our utility clients, this is a balance of plant system where they have a hydraulic fluid called fire resistant fluid or FRF fluid, which degrades during use. And we found a solution for that, and the solution is engineering design change. We also found another solution where we put together a set of unit operations that removes the contaminants from the fluid faster than they are being formed. So long story short, at the end, again, I feel very motivated and fortunate. There was industry recognition there as well with an innovative achievement award in 2016. So having said that, you know, having grown in the industry, I felt now it's time to give back. Now it is time to bring the entire organization together to look at next generation of technologies. So that's where I moved few years ago from being an innovator myself to managing the innovation program, motivating our staff, and creating a robust ecosystem that helps progress innovation and helps Connectrix bring innovative solutions for our utility clients.
As a director of innovation, what do you look for when you're hiring new talent? What are some of the skills that you look for when whether it be skill, whether it be a certain interest, whether it be a certain type of energy? What makes a young professional perfect for like an innovation role?
There are few key skill sets that are required for success in an innovation role that I look for. The number one is critical thinking and problem solving. Are you able to go beyond your comfort zone and look at subject matters that you have not learned in school, for example, or that you are not very familiar with? The next skill I look at is, and I tell this to all the aspiring talent that wants to come into the industry as well. One needs to have at least two skill sets above and beyond what one would consider prerequisite skill sets. So a prerequisite could be an engineering or a science degree, it could be a nuclear engineering degree or mechanical or electrical or whatever, or even science degrees like chemistry, physics, biology, etc. But those are the prerequisite skills, and On top of that, you need to have at least two or three. And what might that be is the key question. And this is something that aspiring talent should listen to, and I think it will be very helpful to them for in terms of growing their own career. One thing is project management. This goes beyond coursework in project management. It goes into practical project management, how things get done. And the other element is what I would broadly classify in a big bucket called communication skills. So this is not just being able to articulate your thought processes or articulate technical information, whether in written form or in verbal form. This also includes, communication skills as relation in relation to business development, sales and marketing, and those are other skill sets that are very important. And but very importantly, when I look for, especially when I look for co-op students or young talent to come into my group, I look for some experience. I look for some experience in these areas that I mentioned. I mean, have they done any past co-op terms that have exposed them to commercial or industrial scale project management, or industrial or commercial scale technical work, where they are able to, where they have showcased their ability to move into new technical areas that they have not learned in school and been and have demonstrated success in it. So those are the key skill sets I look at. The other thing is, skill set I also think is very important for success in one's career is what I call a student mindset. I consider myself, I've been in the industry for close to 27, 28 years. I still consider myself as a student because I am constantly learning. And does the candidate have a continuous learning mindset? What do they learn to keep, uh, you know, up to, abreast of the latest technologies? Are they reading books? Are they listening to good podcasts? How are they learning? What is their mindset in terms of continuous learning? That is something that I look for.
I love how you see the degree itself and those qualifications as the baseline, kind of the foundation, and then you build upon it, right? Build on top of it. And so like a lot of students, a lot of early career professionals, they may say that, hey, listen, Sriram, easier said than done. How am I supposed to do a full time job and develop sales and marketing skills on the side? How am I supposed to do a full time job and develop these skills in sequence? Do you have any recommendations for how early career professionals can do that?
I do have, and let me tell you what I have done within Kinectrics, within my own team in Kinectrics. Uh, we are looking at the latest and greatest in terms of innovation. We are being good examples, or good champions for what the next generation of technologies could be. And so we are researching. We are preparing white papers on a number of new technologies. So we are looking at different levels of innovation, what I call as incremental innovations, small improvements. We are also looking at what is called transformational innovation, next generation of technologies. We are also looking at a third generation, which I refer to as disruptive technologies. So, having said that, how does one, is it possible for a new, young, aspiring, person who's coming into the industry to do it? The answer is yes. We have to combine what I refer to as both hard work as well as smart work. So, what is that smart work approach to training students? For co-op students, for example, this is what I do in my own team. We have about 3 weeks of intense training. This starts with, because many of the students are not from nuclear engineering programs, but they're from general engineering or science programs. So they go through Can-Do overview training, which is very robust training process that we have. They go through nuclear 101 because it's not enough to know just about Can-Do reactors. We need to know about other reactor technologies, boiling water, pressurized water, SMRs. We also need to know about fusion technologies. So that's what I call nuclear 101. In addition to that, they learn about project management. They also learn about what I refer to as innovation program management. So there are different elements to it. How do you innovate? How do you ideate? How do you incubate? How do you commercialize? So all of those 3 weeks of intense training, followed by what I refer to as an atomic habits approach to training. So every month there are 2 or 3 sessions organized per month. These are lunchtime sessions. We call them technical excellence and innovation seminars, or lunch and learns. In these seminars, we invite both our internal experts as well as industry stakeholders and academic professors as well. So we alternate between them, because we realize that we can't do innovation in a silo. We need to expand our horizon. We need to understand what the experts, the academics are doing, what other our peers in the industry are doing. So through this, they have 3 hours of training per month. And the reason I call it atomic habits is when you multiply 3 hours per month by 12 months, typically that is about 36 hours of latest and greatest training that they give. And we also save these PowerPoint presentations and video recordings internally in our database. Having said that, we have close to 100 hours of recorded sessions on everything from artificial intelligence, machine learning to waste management and design engineering and in between. And so number of training sessions available there. We also have what I call a strong mentorship program. So this mentorship is works in two ways. One is what I call a buddy mentor, which is somebody who spent a little more time with the team than the newcomers, who's able to sort of mentor and guide, and that also helps them with their leadership skills, by the way. Then the other mentorship program is which I the one-on-ones I have with my team. Every week we talk about different elements. For example, last week I was talking to one of my co-op students in our mentorship sessions about negotiation skills and about the fact that there is a negotiation methodology called tactical empathy and how that can be used to negotiate. And these are all, and I think that 1 hour of learning, and along with a case study, a real life case study that where I was personally involved in deploying it. So this is just one example. So bottom line is a combination of initial intense training followed by an atomic habits approach to training throughout their term, including and also including mentorship and periodic training sessions which Kinectrics organizes for our client sessions. For example, we do an entire week's course on fuel channels. We do an entire week's course on decommissioning. Now, having said that, I mean, can we bring that in-house and have our people attend those sessions as well? So, combining various such elements, what I have done within my own team is create a robust ecosystem where we are continuously learning, we are growing, and also the important thing to remember is that I previously mentioned about a student mindset, and that I consider myself also a student. I've just spent more time in the industry as a student, that's all. And I think I have to consider how I grow myself. I consistently listen to podcasts. And I believe that one can learn from everybody around you. It doesn't have to be the experts alone. I learn a lot of things from my co-op students too, and our graduate trainees as well, and in addition to the experts within who are around me. So learning can occur anywhere. Having also what I call productive habits. Productive habits could be, I mean, as I give a simple example, I prepared for my entire project management professional exam on the road. So I got a book in a CD, and I had an option of whether I would listen to the usual things that people do while traveling, the radio stations or some news channel. Instead of that, for about a month and a half or 2 months, I was listening to PMP course CD, and I think that is in my mind is a productive approach to and focusing on career growth and learning, continuous learning. There are a few other elements that I also do practice myself, and I hope that will be a motivating factor for aspiring candidates who are coming into the industry as well. Is I try to read a book a week, and it's very diverse. Everything from technology, science and technology, to motivation and business or development, finance even. Right? I mean, that's another area. When I said you need to have two or more areas, non prerequisite skills, finance is another one. Understanding the fundamentals of finance is very very important, because in a commercial industrial setting we have to have a good feel. We have to have our pulse on the finance elements of it, in addition to the technical and project management other elements as well.
First of all, I love the robust investment in youth and early career youth, especially using lunch times. I think that's ideal, right? Because it's time where you're free. You're not, you don't really have, you're not occupied. You have a set time frame where everyone's free, and so providing training during that time is incredible and compounds, right? From what I can see.
There is one other element, Osama, I would like to add in all of this. We are also trying to make workplace a fun place to be, and there are a few things we do for that as well. This includes, periodic get-together sessions like board games in evenings, playing spike ball during lunchtime in summer in our courtyard. We have an on-site gym as well, and in addition, also giving back to the community. Whether our involvement in United Way or Young Street Mission and other such giving back to the, or even indigenous events where we contribute to and participate in. I think that creates a holistic environment of learning, a growth, innovation, and a solid ecosystem that is not just super technical alone or business only, but it also has that other holistic elements that we bring in, which makes work a fun place to be. And it also builds that overall camaraderie that I call it. Getting to know people, networking, learning from each other. It creates a solid ecosystem.
Like that balance between work and play, right? Like I think you really need both to grow as a professional, and also, and like what you do every day, right? Come in, feel comfortable. I know those outside of the industry, when they look at the industry, they get kind of confused, right? Because they see utilities, they see engineering consulting firms, they see vendors, construction firms. What is an engineering consulting firm? What is Kinectrics?
Good question, Osama. To the people who are aspiring to be in the nuclear industry and are not very familiar with the industry, this is how I describe what Kinectrics does. When the smart engineers and scientists in the utility organizations, these are our utility client organizations, when they have a challenge, they come to the smart engineers and scientists of Kinectrics to solve those challenges. So we work very closely with our client organizations to understand their challenges and come up with innovative solutions to address those challenges. Having said that, in order to understand, there is a role for every candidate who wants to come into the industry. And I think the best thing that a new candidate, aspiring candidate, might want to look at is what is the best fit for them in terms of their skill sets, in terms of what they want in a job. I think if you look at the utility world, for example, the focus is, of course, power production. Producing power in a safe, reliable, cost effective manner is the primary focus of the utility companies. The primary focus of consulting engineering companies like Kinectrics, who also, in addition to do consulting work, we have our own state-of-the-art facilities, etc. Our job is to reach out to our customers, understand their problems, and come up with innovative solutions to solve them. So we try to help them through our solutions. So we are very solution-centric, solution-focused, problem-solving oriented. We like to talk to our customers, and like to understand what their challenges are and try to solve. So we are in the problem solving world, and we try to make things easier for our client organizations. So a simple case in point is, historically the nuclear industry has been a lot of things are still done in a paper based type approach. We have brought in digital innovation there, digitization of records, automation, auto analysis, for example, of inspection data. So we're trying to help our utility clients do their work, better, faster, cheaper, more cost effectively, more efficiently, right? So we are trying to, that's what we do for a living, and we are very project based, so it's very fast paced. So in order to be comfortable in the consulting world, one needs to be comfortable with the fact that it is very project oriented, projectized, and it changes constantly. There is a uh, there is a thrill about it. There is also a hustle about it, and there is also a satisfaction that at the end of the day you have solved a problem. And for a customer or for the world in general, in terms of our isotope project, medical isotope project, we are solving a worldwide problem of cancer through that, right? So ultimately, it gives us that satisfaction. So every company in this industry has got a different role to play, and ultimately, for the success of the industry, we need to all come together, and we are just, it's like a team. Let's say a soccer team, and you have the goaltenders and the defense line, the midfielders and the forwards. I mean, for the success of the team, in my mind, the nuclear industry is what I call Team Canada. We have to come together collaboratively. We just have different roles to play for the success, to solve world problems. And we are at a critical stage in the world, be it the climate change crisis or the energy crisis or the the medical issues with cancer creeping up. We are here to solve problems, and we can't do it alone. We have to do it collaboratively. We have to work together.
Some folks, when they think of consulting firm, they think of PowerPoint presentations and really just like sales and marketing, and they don't really understand the scope of the technology and maybe product development that goes behind that. Could you give a bit of a deep dive into that technology aspect and its combination with providing that sales and marketing and business development? How do those two functions? What are the cross sections in between them?
There are the first thing for us is always to understand the customer need or the industry need. Once you understand that, we have to get to, if there is a challenge, for example, in a plant where we have to address a nagging issue, that is possibly impacting a particular system or subsystem in a plant. We What we do as consulting engineers and scientists is to go in and understand the root cause. So that is a root cause assessment that we do. Once we do the root cause assessment, we have to come up with a solution too. The solution is not just what uh, you know what one thinks of as a paper solution or something that you can do with your computer. The solution also involves going into the facility, developing a set of and I'll give you a case in point where Kinectrics did this very successfully for the Kando industry itself. There was this balance of plant system where they had a challenge with a hydraulic fluid in the system that was degrading during use, and we identified the root cause as some challenges associated with the design, because these were all designed several decades ago, right? So there is always scope for improvement. So once we identified the root cause, we also provided a solution. And I'm happy to say that in all in several of the refurbishments that are occurring in the Kando sector today, those that engineering design change recommendation that we provided has been accepted by the client and it's being implemented. Now, having said that, in the interim, we also needed to develop a solution where we have a set of unit operations that removes the contaminant from the solution faster than it's being formed. This contaminant was causing some challenges downstream. And so, coming up with a set of unit operations, we had to go into the lab, do some test work, bench scale work. So we had to come up with a set of unit operations. These unit operations are treatment technologies that remove the contaminants in the first understanding what kind of contaminants are there. Sometimes it's first of a kind. So we take samples from the station,
Yeah.
we do a suite of analysis. So we go into our analytical lab and we do about 20, 30 different analysis. These are called control and diagnostic parameters. So we try to understand what is really causing that. See, in a production environment, there's no time to look at deep dive into some of those minute things. That's what we do for our customers. We look at the problem, then we identified issues around that even the industry was not aware of.
Yeah.
And once we identified those issues, now we have to solve the problem. So we identified that there are three important components to the contaminants. There is an insoluble component, there is a soluble component, and there is also an inorganic and organic component to element. So we needed three unit operations. So we came up with not just the unit operations, which are a set of technologies that put together in the right way will remove the contaminations faster than it's being formed, because there are several contaminants in the fluid. And also helping the customer deploy it in the field. So we do everything from understanding the root cause, developing the solution, building the solution, fabricating it, and deploying it in the field. This includes even our flagship tooling technologies like circumferential wet scrape tool, CWest. That is something that we collaborated with our customers. We developed the technology, we built it. We have a state of the art machine shop where we can actually go in and actually build things, fabricate things. And not just that, we also deployed it in the field. So the entire life cycle, so as a consulting engineering and field services company, we go through the entire cycle. We leverage our state-of-the-art facilities very well, right? So that's what gives me satisfaction that I can not only, as a scientist, as an engineer, we can not only look at the problem and come up with a paper solution or a paper assessment of it. We can also develop the entire life cycle solution. Build a set of tools or build a set of unit operations that can be deployed in the field and helping the customer deploy it too. So
Yeah.
the whole life cycle.
I like how you gave like real life examples, and that really helps the audience understand deeper from a ground level what that looks like. You know, the work that you do in terms of engineering consulting. But this was a phenomenal discussion. I really enjoyed it. Thank you so much, Sriram, for this chat. Is there any last message that you'd like to leave with the audience?
I think many of your audience are Generation Z, Osama. So I have a simple message for Generation Z here, and the young and aspiring candidates who are looking for a job in after their graduation. Please consider nuclear. All companies that are actively involved currently in the nuclear world are good companies. And here is why few reasons why you need to be in nuclear. First thing is you're solving three major problems in the world. The first one is climate change crisis. The second is energy crisis. And the third one is cancer, and which the nuclear industry is if there is a beacon of hope here for all these challenges, it is the nuclear industry that is a beacon of hope. And having said that, nuclear industry has played a very consistent, reliable role in addressing these challenges. And what we are trying to do now is, historically, the industry was very good at talking to itself or amongst ourselves. Now we are trying to reach out to the rank and file in terms of the universities, the students who are coming out, the aspiring engineers and scientists, to encourage them to consider nuclear as a career. And so there are a few things there. Nuclear is reliable, scalable. It's also cost effective. It is cheaper than solar, wind, and such technologies. The other thing is it is reliable, scalable, and it is a mature technology too. Nuclear has been going on for a very, very long time. The other thing is about 60 to 70% of electricity, as you know, in Ontario is nuclear generated. So this is stable, long-term jobs that are available to the students. And regardless of how the economy moves, we always need electricity. So these are stable, high-tech jobs. The other thing, when I mean what I mean by high-tech, is not just in terms of new nuclear designs. I'm talking about all the cool technologies that you have heard of. Everything from artificial intelligence and machine learning to virtual augmented reality to smart materials, advanced manufacturing, you name it. The nuclear industry is involved in it. Kinectrics, my company, is involved in it. And I think ultimately, we look, and as I mentioned previously as well, the medical isotopes world, whether it is the cobalt 60 that the nuclear power plants are manufacturing for sterilization of medical products and surgical equipment and PPE, etc., or the medical isotopes that my company, along with Bruce Power and our joint venture partner in Isogen, is doing, which is lutetium 177 to cure prostate cancer. We are doing it all. So this is a very vibrant, forward-thinking, reliable industry, and we do it all by keeping in our core values in mind, which is safety, quality, innovation, collaboration. So these are the elements that we bring together. So please consider a career in nuclear, and to me, that is the future.
Thanks so much for this discussion. I think you motivated a lot of young, bright minds out there, and even for those that are in mid-career or later in their career looking for a bit of a change in industry. So really appreciate the discussion. Thank you so much, Sriram. In the description below, you can find Sriram's contact, and you can reach out to him if you have any questions.
Thank you so much, Osama, and thank you all. Thank you.